Hello everyone, welcome to the YouTube channel of TriboNet. My name is Manoj. Today in this video, let us discuss about the area of contact between moving surfaces experimented by Bowden and Tabor. The introduction to this is, when two plane surfaces come into contact, the true area of intimate contact is far smaller than that of the apparent one. Even high polished flat surfaces have microscopic hills and valleys or asperities, and the upper surface rests on these, leaving the large gaps in between much larger than molecular dimensions. The exact nature of these irregularities and surface flatness remains unclear and varies under static and dynamic contact. Studying how contact area changes during the motion through electrical properties is very crucial, and hence the Bowden and Tabor's experiment offers a valuable insights into this. What are the experimentation and the methodology they used? They used the two cross cylinders which were arranged with their axes at the right angles, and the electrical conductance capital A was measured using a current potential method. Here, a known current, that is small I, was passed through the contact, and the potential difference V was measured using the high resistance potentiometer or galvanometer, and the conductance was calculated using capital A is equals to I by V. The load on the contact surfaces was varied by using water or mercury, adjusting using the weight, and the load ranged from 20 grams to 6,000 grams, applying larger loads up to 1000 kgs with a lever machine and a spring balance. The contact surfaces was prepared through a fine grinding, polishing, chemical etching or scraping. Although surface preparation had minimal impact on the results, scraping improved the reproducibility. What did they modify within this experiments? The measurements were extended to moving surfaces with the method like the previous one, which we also saw in the stationary in the previous video, but with the potentiometer replaced by the rapid response instrument like Eindhoven galvanometer or a cathode ray oscillograph. Friction was measured using a high frequency apparatus like that described in the previous video. The lower surfaces in the form of a flat plate was driven at a constant rate by a water piston. The upper surface which rested onto it was typically curved. Both the conductance and the friction measurements were recorded simultaneously using same moving film camera, ensuring a synchronized record of both quantities. What did they find? What were the important results and discussions? Experiments showing the contact area between moving surfaces fluctuates. Even though average conductance matches with the stationary surfaces, these changes align with the stick-slip behavior, friction behavior, and vary by metal type. For a hard curved surface slider on a soft metal, contact area grows during the sticking and dropping suddenly during the slipping, supporting this idea that the friction comes from the harder metal asperities flowing through a softer surface, leaving characteristic scratches. When a low melting slides on the high melting one, the conductance drops during the stick phase and peaks during the slips. This suggests the frictional heat and the pressure cause the softer metal to weld onto the harder one, increasing the contact. As pulling continues, these welded spots thin and eventually breaks, causing the slip, repeating the cycle. When both surfaces are made up of the same metal, the conductance measurements show that the area of contact is somewhat greater than and remains much more constant during the sliding. During the sliding, only small variations in the conductance occurs, and the friction is very high, exhibiting slow fluctuations, and the characteristic tone track is formed. This behavior is generally observed within the similar metals as long as they are homogeneous. These conductance measurements support that the suggestions that in the case of the similar metals, mutual welding of these two surfaces takes place, and the local high pressures and the temperatures causes both surfaces to flow, contributing equally to the formation of the welded junctions. And these mutual junctions are likely easier to form, resulting in a greater real area of contact and increased friction. When the movements occur, both surfaces are damaged, and the metal in the resulting track becomes severely distorted and torn. These were the important findings of the experiments with respect to the moving surfaces. And what were the conclusions? The measurements with the moving surfaces revealed that the area of contact fluctuations rapidly changes during the sliding, and these fluctuations are closely correlated with the changes in the friction and temperature, indicating that the intermittent clutching and breaking away of the surfaces with the metallic junctions being formed and broken. The nature of these junctions depends on the physical properties of the metals involved. Even when the metals are lubricated with the mineral oils or the other lubricants, metallic contact can still occur, though through the different lubricant films, and fluctuations in the area of the contact are observed during the sliding, and the behavior may be similar to that of the unlubricated surfaces. This is the reference for the information provided in this video, and in this video we understood what are the introduction to the area of contact between the moving surfaces within the Bowden and Tabor's experiments, what are their methodology used and the modifications to that methodology, and what were the important results and findings of their methods. Thank you for watching this video, and to get more details on the topic of tribology, follow us on our social media pages on Instagram, Facebook, LinkedIn, and do not forget to subscribe to our YouTube channel TriboNet. Also visit our website on www.tribonet.org.